like 10-minute, 5-minute, 2-minute stop signs.
Well, we'd say it's 25, right? 25 minutes.
So otherwise we're watching for 9:45 on the clock, but I can't see from where I'm sitting. I would still be able to see that. That's fine.
Well, no, but now.
Oh, now I can see.
Now you get a clear shot. I don't know, did they tell us? I wasn't watching. Did they tell us when to go? Okay. I figured somebody, I think they usually close the doors.
Yeah, turn on the microphone. This time.
No, it's on. It's on. Excellent. Good morning. Thank you. Thank you very much for getting up so early. I know I did. My name is Michael. This is Kevin. We're here to talk today about building your own multi-user password management using open source software, and why we decided to do this.
So a little bit about us. We both work for Sikich. It's a professional services firm. What we do for Sikich is mainly penetration testing, but we get involved in all the other stuff too, forensic investigations and risk assessments and all that kind of stuff. And we're hiring if you're looking for a job and doing that kind of stuff.
All right, so the idea behind this is we have a team of penetration testers, about 7 of us now, and we have this automated process where we send out laptops into the field for a client. The process has gotten extremely automated over the years, which I'm very proud of, but the next big evolution was to figure out a way to capture the passwords for these systems, because right now a human has to type them in and we have to put them into our password, our KeePass database, right, and then we forget, or somebody doesn't put it in or save it correctly, or whatever it is, right, and then all of a sudden a consultant is sitting there going, I can't get into XYZ client, right, and then we have to figure out who made that box. So with the build process getting more and more automated, we thought, well, now's a good time to sort of create this automated way to store passwords. This has sort of been in my brain for a couple of years now. So we thought, well, how can we do this in an automated way?
And I think the really, early on we're like, and when we build this, that's a cool topic. Let's do a talk on it. It'll be easy.
Right? Yeah, it was kind of like, well, KeePass, everyone uses KeePass, it's open source. Hasn't anyone ever created a way to store passwords in a database or flat file or something that can be secured and then used by lots of different people? Like, this should be a product already, right?
A free product.
A free product.
There's certainly commercial ones out there.
Yes. We're, Kevin didn't mention we're also very cheap. So pretty much all this entire process that we've built this from is all open source software. So again, the idea is, how can we do this so that everyone can access it? So we went ahead and thought of creating key pairs, PGP, right? Public-private key pairs. We had a lot of don't know, I'll say discussions about how to do this. In my brain, I always thought PGP keys would be the best, and then we would encrypt the passwords, store them in the database, and then when they wanted to come out, the user could use their keys to get them out of the database, right? So my original idea was to create a server side. If you want to think of the server as a person, the server would have a public-private key pair, right? And then do it that way.
Yeah, so the key things, again, we thought, let's use GPG because it's open source and vetted and all that kind of stuff. And the public-private key pairs let us, for example, someone who doesn't need to read any passwords can still put a password in the database. For example, our build host that builds these servers can put a password in the database because it just uses the public key to do that. And we get some layer of kind of MFA in that people are using password protection on their own private keys when they go to pull stuff out of the database. So we said, this just seems straightforward, easy, we'll just use GPG and script it up, it'll be done. Awesome.
Right. Yeah, he gave me like 4 hours to do it. He's a nice guy. So very quickly, we started having our conversations about how do we do this. A lot of the other build process is using MySQL in the back end. So I thought, well, why don't we just expand that and keep using a database, right? Pretty easy. Kevin thought differently. He wanted to use flat files.
Yeah, we'll go through a lot of these design disagreements, but really what we found, like lots of back of the napkin discussions, lots of whiteboard discussions, and every decision we think we made, we would back up when we try and make another decision. You know, and as Michael said, one of the first one was, where are we going to store the passwords? I was pushing for kind of flat files, partially because we were like, let's build this tool, make it open source, bring it to DerbyCon. And so, okay, well, flat files, no need for a dedicated server, you can just store the stuff anywhere, and let's just keep all the security off the server, you know, everything's gonna be encrypted there anyway, just put it on a file server, put it on a cloud storage, who cares, it's all encrypted.
Kevin's nuts, so I went ahead and convinced him to use a database and put all the security on the server, because I wanted to.
And then, yeah, the next question was, where do we allow this decryption to happen? I, again, was pushing for, well, it should all happen on the client. Like, you never want to decrypt on the server. Why have any security on the server when you just need the password on the client? You know, I want that server to be, let's put that server on the Wi-Fi at Starbucks, and who cares about it? That quickly got complex when we looked at the other aspects like key rotation, where we have to change every password in the system. But I still thought it was a good idea.
You're entitled to your opinion. Yeah, it's a great idea because client-side security is awesome. So what we decided is to put it all on the server so that way we can control it, right, and have access around that particular box. And if you read the sort of blurb in the brochure of this, I'm not a cloud storage fan. I do not like putting my passwords in the cloud. I don't even like having my email in the cloud, but you know, that was cool. So then we decided we had to start talking about how do we encrypt it. So once I convinced Kevin that we needed to use a database, we started thinking about how do we encrypt these particular passwords. So
yeah, I was still a big fan of the why do we need a server key? Just use every user's public key to encrypt every password. You know, if I talk to people who like about that, like, okay, this is the password and we just use everybody's public key to encrypt it, everybody says, that makes sense. I understand what you're doing. But that adds a lot of complexity in terms of, okay, when you need to rotate that password, you've got to re-encrypt it with everybody's public key. And just thinking about, if you take one, you know, 16-character password and encrypt it with a dozen public keys, you're actually storing a pretty large chunk of data for that one little password. So it wasn't great, but I still like the idea.
Yeah, I mean, we have like 7 people on our team, so it's not too bad. I mean, that wouldn't be huge, but it doesn't scale well, right? So if you have a team of 100, 200 people, that's going to become really cumbersome really quickly. And so that was kind of one of the design decisions. It would work well for us, but I sort of wanted to make it work well for everybody. So then we came up with the idea of using a single password, like I talked about in the beginning, of having a server public-private key pair. And in that situation, you have a single public key that is encrypting all the passwords in the database, right? And then we protect that private key. The other idea was to use a unique public-private key pair for each password that's stored in the database. But again, that was also had a lot of issues when we start talking about how do we rotate those keys if somebody leaves our environment, password changes, whatever it is. How do we go through and change all those passwords in a timely manner, right? Anything else you got?
Yep. That's it. And all that tied into when are we going to rotate encryption keys? Obviously, if someone leaves our team, doesn't happen often, but we want to rotate the keys in case they'd taken a copy of it or could still get into it. It doesn't happen often. Should we just have that be a manual process? Because we're using GPG and scripts around this, so we could just do it manually, what needs to be done. Seems like a bad idea, though. We talked at length about the third option here, the add each password lookup. Like, wouldn't it be cool if after I decrypt this password in the database, every time I'm going to re-encrypt it with a new key, so that even if that other key was stolen when I decrypted it, you wouldn't be able to pull that password out and get it again or get other passwords from the database. So very kind of secure option there. But as you can expect, the complexity of, okay, every time I read a password, I'm going to go back in and re-encrypt it, and the database was like, maybe we don't want to go down that path. A lot of our design decisions, as this got as complicated as it did, like, we made design decisions based on what's going to work best for our team and gave up a lot of the what's going to be the coolest tool for the community, because really our first goal was we need this for our team.
Yes, and I think the last point that we talked about at length on this particular one is because we were talking about doing everything on the client side. So the idea was if the client had that server's private key that could decrypt that password, we would rotate and change that out. So if the client got compromised, that server's private key wouldn't be exposed. Right, that was the idea behind this. So that's why I went back to, well, why don't we just keep it all on the server? Because now the server is quote unquote secure, and we don't have to worry about transmitting those private keys across. Right. It's one of the few battles I won.
So we spent a lot of time on discussions, and we both went down different paths building our own proofs of concepts that were completely different. But out of that, we got a lot of these great takeaways of this is harder than it looks, and there are a lot of different directions you could take. And like I said, we gotta just, poo or get off the pot. So let's build what we need for our team and kind of share what we learned through that process.
Yeah, absolutely. So that's kind of what we came down to is this doesn't really exist yet. It is actually a lot harder than you would thought it would be. So what we ended up doing is we created this product open source tool. We call it the Password Cube. We were in a team meeting. I was demonstrating this to our colleagues, and I'm a fairly large Star Trek nerd. So one of my colleagues, Ethan, decided to tell me that we should make it like the Borg because we're assimilating all the passwords. So we decided to make it a cube. But real simply, it's used the MySQL database. All encryption, decryption, everything happens on the server. So all the security is around the server itself. We wrote this in Bash because, like Kevin said, we sort of went down our own paths to do sort of a proof of concept.
I wrote mine in Perl, and everybody laughed at me.
He drinks a lot. I used Bash because Bash is awesome. I think it's awesome.
You just can't handle the Perl.
I have taste. So then, to get into the system, everything is using SSH, of course, right? So we use our SSH keys to get into the box, our public-private key pairs there, which we've kind of all sort of agreed on as a community that's secure, right? On the server itself, let's see, it's got its own public-private key pair, and we rotate the server keys as needed. Generally, when somebody leaves the organization, which we haven't had to do yet. And if you're interested in looking at it, the link is on the screen right there. It'll be up for a little while, but it's it's on our GitHub repo. All right, so kind of why did we do what we did? I think I already talked about this, but the SSH portion, so if you've got your public-private keys for SSH, and you have a passphrase on your private SSH key, right? Someone would have to steal your key and then also your password to get into the server, and hopefully we would figure that out sooner rather than later.
Yeah, so we really have 2 layers of security here. You have to first SSH into the server before you can start to try and look up keys, and then you have to actually authenticate against your GPG key to actually look up a password. So it seemed, again, much more secure than doing all that decryption on the client side.
Yeah, so to get in, like Kevin said, we have to use our SSH keys. Then it has GPG client key pairs, or excuse me, public-private key pairs on the actual box itself, which never actually leave the box. And again, why Bash? Because I think it's a fantastic, useful scripting language. This isn't really built for speed, high processing, anything like that. I don't really need C or anything crazy. It's just basically a wrapper that goes around other tools that are sitting on your Linux box, right? So GPG, because it's an industry standard, everybody likes it.
Yeah, and the combination of Bash and GPG was important for us. It had some drawbacks, and Mike will talk about that, like one of the key ones in the memory in a bit. But it had some drawbacks but we felt like, okay, if we're building some kind of security encryption solution, we want it to be as transparent as possible for someone to look at that and say, yeah, you didn't do something stupid or roll your own encryption or something. So it really is just a bunch of command lines in Bash run against GPG, and pretty straightforward to see what the tool's doing at every single step.
Yeah, and I think that's really important. I'm sure you figured it out by now, but we did not roll our own crypto. We are just using GPG, right? So if there's a flaw in GPG, don't blame us. But when it comes to storing the information, so we've got the age-old battle, if you're familiar with RAM disks. We have TempFS versus like RAMFS and some of the other things out there.
And actually, to step back, so why even use this? It turns out for a lot of stuff you can pipe data into GPG, pipe data out of GPG, but there's certain parts of GPG that it requires reading a file off the disk to decrypt. Is it to decrypt the file?
Yeah.
So to get the signature, to get the key.
Specifically, unless somebody knows more than, well, a lot of people know more than me, but GPG, to decrypt the password, it needed to use the private key of the server, which needs to be on a key ring. So you can't point it at a key like in memory or pipe it in or anything like that. You have to actually point it at a key ring file.
Key ring on the disk.
Yeah, so that's why I ended up needing to create some kind of a RAM disk.
Because we wanted to write nothing sensitive to the disk as part of this.
That was one of the original design goals, which it didn't work. But so I had a lengthy discussion with a friend of mine about TempFS versus RAMFS. If anyone knows a lot about these or has ever looked into these, so RAMFS is great. You can lock it into physical memory. You can kind of dictate, that it's going to sit there, and when it gets destroyed and all the other good stuff, and wipe it out, which is fantastic. But the first thing I found is RAMFS is only usable by root. So in order to give all of my users access to the RAMFS, I would need to actually sort of unsecure my system and give them all kinds of chmod and change mod, and change ownership and all this other kind of stuff. I didn't want to go that way. When I use TempFS, although it is a little bit more loose in the fact that it can be either in physical memory or in swap, the advantage is I can dictate who has ownership or use of that particular RAM disk when it's being created. So I can kind of limit my exposure in that way, right? So I created, if you can look at the code, but basically what we did is we just created a user account, a group that all the user accounts go into, and say this group, has ownership over this particular RAMFS.
So at that step in the process, we create a very small TempFS drive, disk drive, write the server's private key to it, use it by GPG, and then wipe it and get rid of that TempFS.
Yeah, so anything that's actually stored on disk is always encrypted. It only gets decrypted in the TempFS. So I like pictures, so I drew this picture. Basically, this is what we just talked about. We've got the server public-private key pair. We have a public-private key pair for each individual user on the system. What we're doing is we're taking that server's private key and we're encrypting it with every user's public key. And then that particular key is then stored on the file system, right? So it's encrypted in that way. And it also then gets removed from the server. So it deletes the key. So it no longer exists unless it's encrypted, right? The public key gets before it gets deleted, it gets exported. It's public, so it can just sit there, that's fine. And then what we do is we put in the password that we want to encrypt. We encrypt that particular password with the server's public key, and then we store that into the database, right? The user comes along, they log into the box using SSH with their passphrase for their SSH key. They look up the user, the client information in the database. They use their private, their private PGP key, which can decrypt the private
server's private PGP.
I like to get this messed up. The private PGP key of the server, which then can decrypt the password and then give you the raw output. Right. Also, there's a step that's not illustrated here that in order to store this, if you've ever looked at PGP data, it's kind of like, I don't know if it's actually binary, but it's not pretty. So there's actually an extra step in here that I'm base64 encoding it, just so it's a nice text string so I can store it in the database neatly. And then so it's not, you'll see that it's base64 encoded. That has nothing to do with security, I get it. It's just so that it's a nice, simple text string to work with.
Now demo.
Video demo.
Video demo, because I forgot to sacrifice a goat this morning to the demo gods. So what I'm doing here is I'm logging in as myself, MView. I am an administrator on this box. So the first thing you'll notice that I get this special administrator console. Says so right there, and I also have the ability to jump into the user side of it as well if you want. What I'm going to do is look at my users. I've got 2 people in the system right now, Kevin and Will. I'm going to go ahead and add a new user. I'm going to call him John Smith. I lack creativity in my life. So we're going to say John Smith is not an administrator. And all this is really doing in the back end is just creating a Unix, Linux level user, puts this individual in certain groups, make sure that everything is, correct for them. So I mean, you could easily do this from the command line. I'm just super lazy. So I drop in a public key. I used mine just for this demonstration. I'm going to jump over to the other tab here. There we go. I'm going to log in.
So this is a user, not an administrator.
Right. So this is a user I just created, Jay Smith. So Jay Smith is going to log in, and now this individual is just going to get the user menu, so no administrator access. They can look up passwords, add passwords, whatever. The first step they need to do is generate their own GPG keys, right? I thought about this just the other day. I'm going to change this a little bit to force the individual to actually create their keys the first time they log in. But this is an important message down at the bottom of the screen if you can see it, but this individual still does not have access to the passwords in the database until the administrator re-encrypts the public key, the private key with their public key, right? So the user has created them, that's fantastic, but they still can't do anything.
Yeah, so that's an important point. Every time we sorry, I'm going to pause it. Every time we either add a user or remove a user, we have to re-encrypt that server public key, either by adding that user's PGP public key to encrypt it, or by removing their public key so they can't get to it anymore.
Right, and so just looking at this real quick, we've got John Smith now added, that's great. So the administrator comes in and re-encrypts the public key. You'll notice here that it's asking me as an administrator to validate who has access. You'll notice that it's MView and J. Smith. You might have noticed that there was no K-Bong or Will on there because they have not yet logged into the system that I so slaved over for days trying to create for them. So they don't have keys on the system yet. Thanks guys. So now this individual, Jay Smith, can log in, put in their creds, and there's the password. We kind of ran out of time. I think we're pretty much done, but otherwise, if you're interested, you want to talk more about it, I'd be happy to. Source code is out there if you want to see the database, the back end, that would be great as well.
So email us if you have questions.
Quick questions? Yeah.
Let's say Kevin gets hit by a bus.
Yes.
Oh. I'm sorry, win the lottery.
No, hit by a bus, that's fine. Hit by a bus.
How would we retrieve is there any way to retrieve his password that they lost for Kevin?
No, so that's the beautiful part is they're actually encrypted with the server's keys. So if Kevin gets hit by a bus as a consultant, we would just take him out, we would remove his public key and re-encrypt the server's private key, and Kevin would just be gone and I would just go about my business.
So everybody on the system has access to all the passwords in this design. One of the designs that I liked that used no server private key allowed you to individualize who can see what passwords, but we didn't go that way.
No. Well, because we trust our team. The point is this is a team-oriented thing, right? I would trust my team.
I see 25 on the clock here. I think we're out of time. So
Thank you.
if you have other questions. Thank you very much.